Students, in this video, I will go through exercise U5A06A, where I will be applying concepts of sine, cosine, and tangent to solve for not sides of right triangles, but rather ratios of sides of right triangles. Let's take a look. So the instruction here reads, find the value of each trigonometric ratio. Okay, I want to go through only the even questions here, as you will use this to model the assignment for, which is going to be all the odd questions. So sine of x, so sine of an angle, the ratio is opposite over the hypotenuse. Cosine of an angle is adjacent over the hypotenuse. And tangent of an angle is opposite over adjacent. Now you have to keep this in mind as you go through these problems here. So now what they're asking you to do is, what is the ratio of sides for sine of x? So x being this angle here, so which side is going to be opposite of x? So when you think of opposite, it's always going to be the side that's facing the angle. So this side here is facing that angle. Which side is going to be the hypotenuse? Now the hypotenuse is always going to be facing the right angle. So it would be 45. Let's take a look at the next one here. Cosine of x, so x is here. I want the side that's adjacent to. Adjacent to, right, is right next to. There are two sides that are technically adjacent to x. You have 37 and you have 35. Which side would be the side that's adjacent, and which side would be the one that is the hypotenuse? Well, the hypotenuse is always going to be opposite of the right angle. So therefore, this side right here is the hypotenuse, and this side is the adjacent. So cosine of x is equal to 35, because that's the adjacent, and the hypotenuse is 37. Another way of thinking about it, the hypotenuse in a right triangle is always going to be the shortest, longest, or the middle side length. Of course, it will be the longest side length. So that's another way of reassuring yourself which one is the hypotenuse. All right, tangent of C. Tangent of C, C is right here. So which side will be opposite and which side will be adjacent to? So the side opposite is going to be the side that's facing angle C, and that would be 8. The side that's adjacent to will be right next to, so it's either 15 or 17. So which one is it? It's got to be 15, because 15 is the shorter. 17 is the hypotenuse. So again, I want opposite over adjacent, and this would be tangent of C. Okay, number 8. Find the missing side round to the nearest tenth. All right, so for question 8, I want to find out what x is. Now x is opposite of 63. 15 here is opposite of 90. So therefore, 15 is the hypotenuse. X is opposite of 63. So what am I going to use? That would be sine of 63. So sine of 63 is equal to opposite over hypotenuse, x over 15. Because sine of x is equal to, sine of 63 is equal to x over 15, I can then figure out what this sine of 63 is using my calculator. So that's what I'm going to do right now. So I want to punch in, in your calculator setting, you're going to press mode. Make sure on the third line there, do you see the setting there is set to degree? Make sure that you have it set to degree and not radians. Okay, press enter and make sure that it's highlighted. I'll press second mode. And what I'm going to do now is I want to press sine of 63 degrees. And that's 0.891006, right? So this is 0.891006. So I want to multiply both sides by 15. And what will I get? So multiply by 15. I'll get 13.365. And it says round to the nearest tenth. So 13.37. So x is approximately 13.37. Now, I just want to make an additional comment to this, okay? There's something else that you can do rather than breaking it up into so many intermediate steps. What you can do in this step here is we can cross multiply by 15, and if we do, we'll end up with x is equal to 15 times sine of 63. If you multiply 15, right, place it out in front, you'll end up with 15 times sine 63. And you know what? If you enter that in the calculator in this one step, you'll get the same answer, 15 times sine of 63. So that's just doing it in one step rather than doing it into multiple steps, okay? So that's approximately 13.37. All right, number 10. So this side here is opposite. This side is the hypotenuse. So how are we going to do this? Opposite of 70, that is, right? So again, we're going to do sine. So sine of 70 is equal to 18 over x, because 18 is opposite and x is the hypotenuse. So rather than entering sine 70 into the calculator, I'm just going to treat sine 70 as if it's a number, okay? Just like the number 3, the number 4. I want to multiply both sides by x. And if I do, I end up with x sine 70 is equal to 18. I divide both sides by sine 70. I end up with x is equal to 18 over sine 70. And this is what I want to enter into a calculator. So I don't have to write down any decimal values. I can just do it all in one step into the calculator. So 18 divided by sine 70. And that would be 19.155 or 19.16. Oh, I'm sorry, it says round to the nearest tenth. I made an error. So this before should be 13.4. And here, this answer is, what was that answer again? 19.2. Okay? All right. So here in this case, x is adjacent to angle 53, and I know the hypotenuse is 16, so I'm going to use cosine. Cosine of 53 is equal to adjacent over hypotenuse, so that's x over 16. I want to multiply both sides by 16. I'll end up with x is equal to 16 cosine 53. I enter that into the calculator. 16 cosine 53. 9.63 or 9.6 rounded to the nearest tenth. So x is approximately equal to 9.6. Number 14. Okay. So I have x is adjacent to 18 and 11 is the hypotenuse. So I want to use cosine is equal to x over 11. I want to cross multiply. So 11 cosine of 18. X therefore is approximately equal to 10.5. And over here, number 16, x is opposite of 37, and 15 is adjacent to 37, so I'm going to use tangent. Cross multiply both sides by 15. So I end up with 15 tangent of 37. 11.3. Okay. Here again, x is opposite of 25, so I can say tangent of 25 is opposite over adjacent. So again, I cross multiply by 12. I get 12 tangent of 25 is equal to x. And what will x turn out to be? 5.6. All right. Next questions. It says find the length of the side labeled x. Round intermediate values to the nearest tenth. Use the rounded values to calculate the next value. Round your final answer to the nearest tenth. Okay, so here we're looking for this guy, and notice that this is not a right triangle. I have 40 and I have 70. That would mean this last angle over here would have to be 70. Right? So technically, we can't really use sine, cosine, or tangent for triangles that are not right triangles. So, and this is what we're about to do is applicable universally. Okay, whenever you are not familiar with something, you want to look for patterns. You want to look for clues to make something look more familiar. All right. So what we're going to do is we're going to manipulate this diagram, but in such a way where we are not going to change anything, okay? So what I'm going to do is I'm going to draw a line down like so. And by drawing this line down, I haven't really changed the original at all, right? I just added in an extra line, right? The original figure is still preserved. Why am I doing this? Well, that's because I'm creating a right triangle. Why am I creating a right triangle? So that I can then apply concepts of sine, cosine, and tangent. So with that in mind now, what I can do, since that line that I drew here is being shared by the triangle on the left and triangle on the right, it wouldn't make sense for us to figure out what that altitude is. So I'm going to call this altitude here h, and if I do, let's solve for h because it's being shared by both triangles. So h is actually opposite of 40, and 39 there is the hypotenuse. I want to use sine is equal to h over 30. And again, I want to solve for h. So h will equal to 30 sine 40. The instruction says to round intermediate values to the nearest tenth. So I need to find out what h is. That is an intermediate value. I want to round that to the nearest tenth. So 30 sine 40. That would be 19.3. And then to find out what x is, I will now take the this triangle on the right. H is opposite of 70, and x is the hypotenuse. So I'm going to say again sine of 70 is equal to h over x. And since I know h, right, h is 19.3. Whoops. I want to replace that in there. And I am going to solve for x. So I'm going to cross multiply both sides by x. And divide both sides by sine 70. So x is equal to 19.3 over sine 70. And I'm going to punch that into the calculator. So 19.3 divided by sine 70, it would be 20.5. Okay? And we're going to do that one more time. So here we need to solve for x. And it's really similar. Even though we're given these two angles over here, right? we can figure out what that third angle is because we know that the sum of the angles inside of a triangle is 180. So that would be, what would that be? 45, right? Because 45 plus 75 is 120. And 120 plus 60 is 180. All right. So again, I'm going to draw a line right down. Not down the middle, but forming an altitude, calling this h. So sine of 45 will equal to h over 43. Multiply both sides by 43, I end up with h is equal to 43 sine 45. H will therefore equal to 30.4 and again, taking what h is, I'm going to use sine of 60 is equal to 30.4 over x. And if I cross multiply, I end up with x sine of 60 is equal to 30.4. Divide both sides by sine 60, x is equal to 30.4 over sine of 60. And this is what I'm going to enter in the calculator. $35.1. And that's it.